Greetings of the day, dear students. We have been discussing the important applications of sanitation microbiology in unit number 2 of this particular course. Another very important aspects in sanitation microbiology which are having a lot of roles and relevance in the public health microbiology is water purification methods. So in your syllabus they have mentioned water purification procedures, water purification methods, various methods of disinfection of drinking water, and this particular topics provides lot of relevance in microbiology and public health microbiology. And as you all know the importance of drinking water, and this is very essential to provide adequate and good quality supply of the drinking water. We have seen, although we are having sufficient drinking water facilities, lot of people they currently lack the drinking water facilities, and it is a prime important for the available water need to be purified. And as an introduction, we should discuss what is the need for water purification approach. According to World Health Organization, in the reports published in 2007, I think that is quite old, 1.1 billion people they don't have adequate water facility, especially the drinking water supply. Then out of that, 88% of 4 billion annual cases of diarrheal diseases are due to the consumption of unsafe water and inadequate sanitization and hygienic practices that is followed in various societies. 1.8 billion people they lost their life every year due to diarrheal diseases and other waterborne infections, and 94% of the cases are controllable or preventable through the modification to the environment and access to the safe water, and take this aspect as a high priority to provide good drinking water facility to the public health. The simplest technique, as you all know, the chlorination, filtration and solar disinfection, and for storing it in a safe container could be a innovative solution for the water purification approach. Then reducing the death from waterborne diseases is a major public health objectives in developing countries, including our nation. The visual inspection, generally if you look the water you cannot determine the water quality. That means the physical inspection that cannot be clearly tells the water quality, whether it is potable or non-potable. Then there are procedures such as boiling or use of household activated carbon filters are available, but these methods are not sufficient for treating the contaminants in the wastewater, especially in killing the microorganism that is present in the water. Even natural spring water must be tested before determining what kind of treatments are required for such kind of water. We have already discussed the various type of the sources of water. Then the chemical and microbiological method used to obtain the information necessary to deciding on the appropriate method that can be used for the purification. There are a lot of chemical and microbiological approaches that can be used to understand what type of deleterious impact in the water and what should be required for the purification of the drinking water. Then this picture indicates the need and relevance of water purification. There many places even the kids carries water and they don't have water. They need to travel so many places, and this is really scary because this kids drinks the water from highly contaminated water, you can see, and this environment you can see there are a lot of contamination. Then then there are a lot of domestic animals and their excreta, and this place is highly contaminated, but still these kids are drinking the water for their survival. They don't have a lack and good quality water. This picture clearly tells what is the need of the existing water, and that is that should be reached to all the levels of the society. Then water purification, it is one of the most important aspects of sanitation microbiology. That is why this particular paper is an applied aspect. That is why how this paper will be useful for the the public health microbiology and controlling the infectious disease. The water purification is the process of removing undesirable chemicals, biological contaminants, suspended solids and gases from the water. So water purification, it's a technique of removing undesirable chemicals, the biological contaminants, suspended solids and some gases present in the water. The main objective is to produce the water potable for specific purpose or fit for a specific purpose, especially the drinking. Most water is purified and disinfected for human consumption, mainly drinking water, but the water purification may also be carried out for the variety of other purposes that include the medical, pharmacological, chemical and industrial purpose. So that means to say water purification cannot be avoided in any of these stages and any of the industry where water is required in an adequate level. The methods used to treat the water, that is some physical process can be used, that is such as filtration, sedimentation, distillation, and in addition to that the biological processes such as slow sand filter or biologically active carbon. The chemical processes can be used such as flocculation and chlorination. In addition, the use of electromagnetic radiation such as ionizing and both the non-ionizing radiations can be used such as ultraviolet, which is a non-ionizing radiation. Then the water purification may helps to reduce the concentration of a particulate matter, including the suspended particle, bacteria, microorganisms, parasites and viruses and other fungi. And it can be also used to reduce or remove the concentration of the range of dissolved and particulate matter, especially some kind of materials that is suspended in nature. Then we have already discussed the major sources of the drinking water, the groundwater such as springs, boreholes or wells, the upland lakes and reservoirs, rivers, canals and lowland reservoirs, then the rainwater, that is atmospheric water, the harvested water from the rain, then the collection of fog, then desalination of seawater, then the surface water. So these are the major sources of drinking water, especially that can be used to drink also, and that we have already discussed. Then this clearly indicate the major water purification steps. The main objective of water purification steps to remove the unwanted or undesired constituents present in the water and make the water to safe to drink or fit for a specific purpose in industry or medical application. Also to remove unwanted constituents in the water and make the water safe to drink or fit for specific purposes such as industrial and medical purpose. So here you can see the overview, simplest flow diagram which shows the purification of the drinking water. So the pumping site, this is a source that can be a river or stream or lake or reservoir or canal or some springs or wells, all those things we have discussed. And you need to screen the water. Then after that you need to pass through a pre-chlorination tank where it will be chlorinated. Then you need to adjust the pH. Then the water need to be transferred to a flocculation tanks, and later it should be reached to a sedimentation tank where removal of microorganisms will be taking place. Then you need to transfer the tank into a filtration. There are a lot of filters are available. Then the last stage is disinfections, and finally after so many stages of disinfection that can be supplied to the network of pipes that we have discussed in the previous class, that will be supplied the water for household, municipal as well as domestic purposes in the community. Then what do you mean by, now we are going to discuss what are the different steps of this water purification. First step is the pre-treatment, especially the pumping and containment. Okay, so the majority of the water from the various sources such as rivers, streams, lake, wells, springs, which wherever water is adequately available, even from canals, okay, so that will be pumped using the good sanitized pipes, and it is a source and is directed to pipes or a holding tank, and the majority of the water will be pumped from its source. We have already discussed, either from groundwater or from surface water sources, or directed into the pumps or the holding tank. Then once it reaches the holding tank, then preliminary screening is happening to remove the larger debris such as the sticks, leaves, rubbish and other large particles such as curtain, boxes, plastic bottles, chapels, cloth, all such kind of things, and which may be interfere with the subsequent purification process. So the bigger particles you need to segregate by using screening protocol. Then the groundwater does not need screening before purification steps. These are the surface water it is required, because surface water consisting of lot of waste dumping, the waste are in much concentration, but the underground water does not need all those steps. Then the next one is storage. So once the water is pre-screened, the water from the rivers may be also be stored in the bankside reservoirs for a period between few days to many months, and to allow natural biological purification to take place, especially some natural biological process, that is algae, bacteria, etc. And this is an important for the treatment by by slow sand filter. Here you can use sand filter also. The storage reservoir provides a buffer against a short period of time, which allows the water supply to be maintained during the transitory pollution incident in the source of river. So the storage reservoir, which provide a buffer against the short period of time, which allow the water supply to be maintained during the pollution incidents in the source of river. The next one is the pre-chlorination. In many plants, the coming water was chlorinated to minimize the growth of fouling organism on the pipework and tanks. So you know that when the chlorine is treated with the water, all the microorganisms, especially bacteria, we have discussed the fecal coliforms, that will be destroyed actually. So chlorine is toxic to this particular bacteria. Then after that you need to adjust the pH. So the pure water, that the pH of pure water is close to 7, that is neither alkaline nor acidic. But in the case of seawater, the pH value that range from 7.5 to 8.4, that is moderately or slightly alkaline. But in the case of fresh water, there are wide range of pH values But sometimes if the water is become acidic lower than 7, lime, soda ash or sodium hydroxide can be added to raise the pH during the water purification procedure. How the water become acidic? We have already seen the acid rain. Okay, so from the sulfur content that is combines with the hydrogen, and that will be reached to sulfuric acid or hydrochloric acid. Then the pollution causes the water into acidic level that can be removed by adding lime or soda ash or sodium hydroxide, making the water alkaline. That helps to coagulation and flocculation process very effectively. You need to make the water, if the pH is very low, you need to increase the pH or enhance the pH. That helps to coagulate or flocculate, which will be removed significant proportion of microorganisms. If the water is too alkaline, you can add the weak acid like carbonic acid or some strong acid in the very weak concentration, hydrochloric acid or sulfuric acid, and that can be used to remove the pH. Then the next one is the coagulation and flocculation. Once the pH is adjusted, then you need to coagulate and flocculate. So one of the first step of water purification process is the coagulation and flocculation. So what is this main important aspect? So there the addition of chemicals to assist the removal of particles in a suspended water. So there are addition of certain chemical, and that helps to remove the suspended particles. The main contaminants such as clay and silt, microorganisms such as bacteria, viruses, protozoa, and the natural organic material. There we have already discussed the addition of inorganic coagulant, that is the major coagulant such as aluminium sulfate or alum, or iron salt such as iron 3 chloride. You can add either alum or iron 3 chloride or any other iron salt. So what will happen? The negative charges on the particles are neutralized by the inorganic coagulant. So this inorganic coagulants by neutralized the negative charges present in the particles. The metal hydroxide precipitates are formed. These precipitates combines with the larger particles under natural condition, that is known as Brownian movement, and which mixes and form flock. Okay, that is known as flocculation. So once the precipitate, once the metal is neutralized by the the waste are neutralized by the inorganic coagulant, the metal hydroxide can be added, that will be precipitate the contaminants, and this precipitate combines to large particles under natural process such as Brownian movement or Brownian motion, which combines and mixes ultimately and form flocks. And this is known as flocculation. What do you mean by flocks? When this particular metal hydroxide precipitate the larger particle, it forms an amorphous metal hydroxide, that is known as flocks. So this amorphous aluminium and iron hydroxide, which absorbs and remove the particles by the subsequent process of sedimentation and filtration. So once you are completing the coagulation, you will be getting coagulation and flocculation. You will be getting the amorphous aluminium or iron hydroxide that will be absorbed and remove the particle, that the particle present this particular contaminant by subsequent steps. Then the next one is sedimentation. So the water coming out of the flocculation tank from the previous step, from flocculation tank, will be entered into the sedimentation tank, that is known as sedimentation basin or clarifier or settling basin. So it is a huge tank with a low water velocities which allows the flock to settle to the bottom. So the flocks, the amorphous aluminium and iron hydroxides, will be settled at the bottom. The sedimentation basin is located close to the flocculation basin, so that the transit between the two process does not permit the settlement or flocks breakup. So generally the flocculation tanks and sedimentation tanks are located very close to each other. Due to the transit between these two tanks, the water transit between these two tanks can be controlled and will not permit the settlement or floc breakup. So once the flocs are reached to the sedimentation tank, it will be settled at the bottom. So the sedimentation basin is a rectangular where water flows from end to end, or circle where it flows from center outward. So the water flows from a particular movement or particular way from a rectangular tank. It flows from the end to end or circular way or centrally outwards. Then finally you will be getting a lot of sludge, and how will store the sludge and remove? So as particles settle at the bottom, especially the flocs, the bottom of the sedimentation basin, a layer of sludge is formed. The sedimentation, the formed flocs material that is settled at the bottom, that combines with all the particulate matter to form something called a sludge, which is formed on the floor of the tank, which must be removed and treated. And this sedimentation basin may be equipped with mechanical cleaning devices that can be used to clean the bottom of the tanks and remove the flocs. So once the flocs are settled at the bottom, then these flocs will be formed in layers of sludge, and that can be removed by several approaches such as mechanical cleaning devices. Then the next one is floc bracket clarifiers. So to remove this particular floc, especially particulate material, by entrapment in a layer of suspended flocs as the water is forced upward. Okay, the removal of a particular material by entrapment in a layer of suspended flocs as the water is forced upwards. The next one is the dissolved air flotation, or DAF. When the particle to be removed do not settle out of the solution easily, when the particles to be removed are not going to settle easily, then this dissolved air flotation can be used. So the air is passed and the flotation mechanism can be used to remove the dissolved component that is present in the water. So this is all about sedimentation. The last step is the filtration. After separating most of the floc from the sedimentation tank, the water will be entered to the filtration tank, where the final step is to remove the remaining suspended particles and unsettled flocs. There will be lot of unsettled flocs. They will be coming after the sedimentation tank. Along with the suspended material, the unsettled flocs should be treated. So that can be used by filtration. There are three types of filter we can use. One is rapid sand filters. Next one is source land filters. Next one is membrane filtration. So the rapid sand filter is the most common type of sand filter, where the water moves vertically through the sand, which has a layer of activated carbon or anthracite coal above the sand. So the sand filter is filled with the activated charcoal, activated carbon, or anthracite coal that is filled in the sand filter, and that will be removed the materials that is present. Then the filters out much smaller particle than the paper and sand filter can. So the filter out much smaller particle than paper and sand can do. So the slow sand filter may be used where there is sufficient land and space, as the water flows very slowly through the filter. So when the slow sand filter use, the process is very slow, where you will be having sufficient land and space that can be implemented in the filtration system. There the slow slant can be used. These filters depend on the biological treatment process for their action than the physical filtration. So these filters are depend on the biological treatment process, okay, than the physical filtration. So that is very, very important. Then the next one is the most effective filtration one is membrane filter. So we will discuss that in detail, the membrane filter. So the membrane filters are widely used for the filtering of both the drinking water and sewages. There are a lot of nitrocellulose membrane. The filters are available, and this can be used to filter the water. Okay, so the water and all the bacteria will be trapped on the membrane, and that particular membrane can be used for the cultivation of bacteria, or that can be simply removed. That we will discuss. So the next one is the disinfection. So the last step of the water purification process, the disinfection, is mainly achieved by both filtering out the harmful microorganism and adding the disinfectant chemical. The major aspects to till this particular step, there will be most of the small quantity waste will be removed, but the microorganism will be remained there, and there you will be adding the disinfectant. There it will kill the microorganism. Finally it will be free from complete microorganism. So the water is disinfected to kill any pathogen which pass through the filters, and to provide the residual dose of disinfectant to kill or inactivate the microorganism that causes severe infectious diseases or that causes harmful condition. So the water is disinfected to kill of the pathogen that is remaining in the previous tanks, and that used to kill there will be loss of there will be certain dose for the disinfectant that can be used to kill this particular microorganism very effectively by using disinfection. The possible pathogens are that can be used to kill the viruses, bacteria, which include Salmonella, Vibrio, Campylobacter and Shigella, and Protozoa including Giardia lamblia that causes giardiasis, and Cryptosporidia. All the things you have already studied in the previous semester. The major methods for the disinfections are chlorination, bromination, iodination, ozone disinfection and ultraviolet disinfection. The chlorination can be chlorine dioxide and chloramination. Okay, chlorine dioxide disinfection and chloramination disinfection. So these are the major overview of the water purification steps. And here you can see the raw water. We'll add the coagulants. There you can see the coagulation tank, as I said. Okay, then it will go to the flocculation tank. The flocks will be produced. Then once the flocks will be removed, settled at then it will be transferred to the sedimentation tank. All the flocks will be settled at the bottom, that is known as sludge, and this will be passed through a filtration unit. Okay, there are a lot of sand filters, okay, that will be acted, and there you will be adding lot of filters and disinfection methods. Okay, then you will be passing the treated water for the distribution and the house consumption. So this is the simplest flow chart of water purification steps. Now we are going to discuss the various methods of disinfection of drinking water. What are the various methods of disinfection of water? So we have already discussed disinfection is the final step where it removes the harmful microorganism that removes without destruction from the sedimentation or flocculation tank. The major approaches for the disinfection of the drinking water are chlorination, bromination, iodination, ozone disinfection and ultraviolet disinfection. Chlorination is the primary method. That are two types: chlorine dioxide disinfection and chloramination process. Now we are going to discuss all those things one by one. First, chlorination. The chlorine disinfection is the most common and powerful disinfection method, that is known as halogenization. As you know, the chlorine is very toxic to the bacteria that removes the chlorine. There are two important methods in which we can use chlorination. One is chloramine, and by use of chlorine dioxide. So generally, the chlorine is a strong oxidant which kills many bacteria, as it is a toxic gas and there is a danger of release associated with its use, because chlorine is highly toxic and it is simply released, as it will create lot of problems in the food web and food chain. Then instead of solving this toxicity of chlorine, you can use sodium hypochlorite. So you can use sodium hypochlorite. So that releases free chlorine when dissolved with water. So that will not be having lot of harmful impact. Then in addition to sodium hypochlorite, you can use calcium hypochlorite for the chlorination, which releases chlorine when interact with the water. But it requires more human contact through opening bags and pouring than the use of gas cylinders or bleach. Okay, so this particular application of a liquid, this is mainly liquid. This is the liquid process, but the solid process, it requires lot of human contacts to the opening of bags and the pouring than the use of gas cylinder or bleach. The generation of liquid sodium hypochlorite. So I told you this is liquid and this is solid. Okay, so the liquid sodium hypochlorite is inexpensive and safer than the use of gas or solid, chlorine. So sodium hypochlorite are more safer than calcium hypochlorite because this is the liquid in form and this is solid in form. But when you use the solid, the human contact will happen by opening the bags and pouring the things than the other things. Then the chlorine level that is estimated by WHO for the safe drinking water to be 4 milligram per liter. That's all about chlorination. Then next one is non-ionizing and ionizing disinfection. The UV radiation, UV light, that is known as non-ionizing radiation, and that is a very effective way of disinfectant by inactivating the cyst and bacteria. So as you all know, the UV radiation penetrates the bacterial nucleic acid, and there it will cause the photochemical oxidation by the formation of thymine dimer, and there will be the replication will be ceased, the microorganism will be died. Then the UV disinfectant effectiveness decreases when the turbidity increases. The effectiveness of UV disinfection will be decreases as the turbidity increases as a result of absorption, scattering and shadowing, which causes lot of suspended solid by using this particular process. And the main disadvantages of the use of UV radiation is that which will not create any residual disinfectant in the water, while this chlorine creates residual disinfectant. So when you treat with the UV radiation, it will not produce any residual disinfectant in the water. So thus it is necessary to add a residual disinfectant after the primary ionization. Then that can be done by the addition of chloramines or any other chlorination aspects. Then chloramines provide an effective residual disinfectant with very few of negative effect of chlorination. But chlorination, it's the lot of negative effect will be there, and the chlorine water that will be having a characteristic smell and odor, but the chloramine will not produce any of the negative impact or drastic effect. Next one, this all about the ionization, non-ionization radiation. In addition to non-ionization radiation such as X-rays, gamma rays and electron beams are useful to sterilize the water. So these techniques are a little bit costly when comparison with the non-ionizing methods, but these are effective methods. Next one is ozone disinfection or ozonation. Ozonation is one of the most important method. This is highly unstable molecule, ozone, you know that O3, which gives up one atom of oxygen, which is providing a powerful oxidizing agent which is toxic to most of the waterborne organisms. So it is very strong and broad spectrum disinfectant. This is very effective method and which inactivate most of the harmful protozoa and bacterial pathogens. Then ozone is made by passing the oxygen through UV light or a cold electric discharge. Okay, when the oxygen is passed through a UV light, it will create ozone, or the electrical discharge, cold electrical discharge also form the ozone. The use of ozone as a disinfectant must be created on site and added to the water by bubble contact. Okay, so that is very important. when you apply the ozone as a disinfectant, it must be applied on site, okay, and it should be added to the water by bubble contact, okay, otherwise there will be lot of issues. Then the advantage of ozone include the production of fewer dangerous byproducts and the absence of taste and odor problem that is very common in the chlorination. Then not only that, no residual zone is left in the water. Although it is a advantage, this seems to be a disadvantage also. Then the main advantage is they have a fewer dangerous byproducts, and there is no problem in the taste or odor. The original taste or odor will be retained, which was the major problem. The chlorinated water, there will be taste difference and odor difference, okay, but there will not be any residual ozone left in the water. Next one is the bromination and iodination. We have already discussed about the chlorination, but other halogens like bromine and iodine also can be used. This bromine and iodine can be used as an effective disinfectant, but when compared with the chlorine in water, the chlorine in water is 3 times more effective as disinfectant than an equivalent concentration of bromine, and 6 times more effective than an equivalent concentration of iodine. So chlorine is so powerful, which is 3 times effective than chlorine and 6 times more effective than iodine, okay. So 6 times more effective than the iodine, and the bromine is 3 times effective than, chlorine is 3 times effective than the bromine, and the chlorine is 6 times effective than the iodine. Iodine mainly used to treat or disinfect in the portable water purification approach, okay, the portable water purification approach that can be transported from one place to another. Next one is the bromine is a common as a disinfectant which can be used to disinfect the swimming pool water, that is periodically disinfect, okay. So the swimming pool water need to be disinfected using the chlorine and the bromine or iodine, okay. The bromine is the major halogen which is used to treat the swimming pool, used as a swimming pool disinfectant. This is all about the different methods used for the disinfection of drinking water. Chlorination by using chloramine and by using chlorine dioxide. Next one is bromination and iodination or ozone disinfection, ultraviolet disinfection. So this is all about this particular thing. So now we can conclude, dear student, we have learned a very important topic which is in sanitation microbiology that offer a lot of hope and societal relevance of microbiology. So we have discussed the introduction, what is the need and necessity for water purification, what are the major problems in the society, the drinking water scarcity, and the water purification. We have discussed an overview of water purification, what are the sources of water. Then we have discussed the steps that is involved in the water purification process. Then we have discussed the objectives or goal. Then we have discussed the pre-treatment, the pumping and containment, screening, storage and pre-chlorination. Then we have discussed the next step, pH adjustment. The next one is coagulation and flocculation. The next one is the sedimentation. Next one is the filtration. The last step is the disinfection. There are various types of disinfection, that is such as chlorination, bromination, iodination, ozone disinfection and UV light disinfection. That's all, dear students, in this particular class. So these are the major references you can use microbiology by Prescott or Pelzer or any basic microbiology textbook. So as you can see in the picture, this is one of the major water purification system. They require a lot of spaces, so many tanks and so many places, okay. So by using the pipeline system, so much of acres of land it is required to construct this particular system. So thank you very much, dear students, for listening this particular class. If you are having any doubts, you can ask me. I hope you understood. Have a great time, have a great learning. Thank you very much.